So yeah, CCV, that Jupyter, that round, that. It takes a bit of time to load. So if you're going via the Jupyter Lab approach, I always go there now. I will be using my local Julia. I feel like I have more control over the whole thing. Okay, and it's kind of like time. Let's see, great people on Zoom. Participants 4, it's great. We have a few people there. Welcome, everybody. Can you hear me? Can I get some feedback on Zoom for those who are connecting remotely?
Sounds great.
Excellent. Thank you very much. So let me get this out of the way, get that out of the way. All right. So I guess we'll start, right? My name is Carlos. I work at CCV. And for the past 6 to 7 months, I've done only coding in Julia as a newcomer. So today, my goal for this talk is to show you the things that I've liked about it. And if you're anything like me, in the future, you may just be using Julia on your next project. So let me show you what's in the program briefly. I have here this OneNote note thing, and I have a few pages. So I have about 6 things that I've chosen to show you. It's kind of like a show and tell, or more like a tell and show of what these things that I like look like actually when you're using the programming language to do some interesting work. Okay, so that's pretty much it. What I'm gonna do, talk about the interactive environment in Julia, the syntax, for loops, and a couple of specific features of the language, such as multiple dispatch, broadcasting, and metaprogramming. Okay, so that's the program. And while your Jupyter Hub launches, kind of wanted to show you a few screenshots that I got from Wikipedia about programming languages that people use in scientific computing. And I want to bring your attention to the release date, or the first appeared year. So in the case of Julia, you can see it first appeared in 2012. So about 10 years ago or so. Over here, I have the corresponding screenshot from MATLAB. They say that the initial release was about 40 years ago. If we scroll down over here, we see Python first appeared about over 30 years ago. And over here, I have the one for R. It's the R terminal. They didn't have like a nice logo up there. But this one first appeared about 30 years ago. So as you can see, Julia is a newcomer, but despite its relatively new inception, it has features that are addressing problems that have surfaced in the last 10 to 15 years. And as you know, if you've done any code maintenance at all, it is a lot harder to add features to a code base after the code has been around for a long time. And that, I feel that's what's happened with languages like Python and R, that the developers have had to hack around to kind of like address the problems that we have today. Instead, Julia has been designed from the get-go with these kinds of the kinds of problems that we have today to address them in the most efficient way. So that's probably the 0th thing that I like about the Julia programming language. Down here, I have a few of the features. I'm not going to show you much about this because I don't want to make this too technical. I want to make this talk to be a lot more hands-on. But to say something about Julia is that it leverages modern computer architecture. 30, 40 years ago, we didn't have computers with lots of memory, distributed capacity, cores and nodes and all this. Julia addresses that. It's able to leverage the kind of technology we have today. It supports concurrent, para, and distributed computing. It's built for speed. It is able to call well-respected C and Fortran libraries, and can also leverage packages that are popular in other computer programming paradigms, such as Python and R. So if you have a package that you just love using in your projects, you can leverage those packages almost seamlessly within Julia as well. And now for the things that I do wanted to tell you about and show you about, let's go to the first one, which is the interactive environment in Julia. Okay, have your environments loaded? You have Julia running?
Yep.
Excellent. So I'm gonna pop my Julia REPL, as they call it, the command line for Julia. And I'm gonna clear my screen here well, let me just load a new one. So from your terminal, you just load Julia. Make the font a little bit bigger. Ensure people in the back can see that. Is that good? People in the back, thank you. And the first thing that I want to show you here is that Julia has several modes of interacting with it. The first one is the Julia mode, which is where you just run your commands as usual. So let's do that. Let's say 2 + 2. You press enter, you get back 4. And if I wanted to take that and multiply it by 3, I can use this ANDS variable, a la MATLAB, and I can interact with results as I go without having to copy code back, put it in, type it into a new function, and so on. So that's a very nice feature. I came from coding in MATLAB, and then I did some code. Before that, I did some R coding, and before that, I did C++ coding. So I've dabbled with many different programming languages. So I can appreciate weaknesses of a language or things that I wish a language had that I could incorporate into my workflow. So I like, from MATLAB, having been a MATLAB user, I appreciate this ANDS, putting the last result into the ANDS variable so I can prototype with those results quickly. And it seems like we have the pizza, so let's take a break, eat, and then come back. Let's do maybe 10 minutes. Oh.
Yeah, you're like, but basically like a large kind because he applies for the teacher, they're currently being well, they currently have right now. There's one goes into like they talk about yeah. I guess a lot of that. Maybe yeah, I think so. Around. It should have like. It's hard to just. Right now, we just keep notes on the. So you have. Used to be nowadays. Almost 40 years. I think eventually it's like research and so on. But my role is more like software engineer, so it's like I'm just kind of research instead of students.
What can we continue? You can continue to enjoy your food. Whatever. But I run short on time. Let's take a look. There's no audio.
Just during the break.
Oh yeah. Let's see. Can people on Zoom hear me? We just took a break because the food over here at the Data Science Initiative had arrived. Yeah, thank you. Oh, sorry about that. Because the audio is breaking up. Maybe I'll just stay put here. Make sure that the audio is good. Yeah. Okay. Thanks for the feedback. I'll try to just stay put. Okay, so we're gonna restart. So the ends variable, very nice. And it also has your standard features like completion with tab. So let's say I want to do print something and I press tab a couple times, I get some options. So that's good. It also has history with up arrow. You can also type a few letters, say ands, and then do up arrow and get some suggestions depending on what you've typed. So that's great. But besides the Julia mode or command mode, the Julia REPL has 3 other modes of operation. Let's say that I wanted to build some random array to prototype some functions, but I'm not sure how to do that. So we could go to help mode with question mark. So I'm going to type question mark here and know how the prompt changed to help question mark. Now we can do documentation lookups. So I want to do rand, maybe is a good start. And I'm going to press tab and see what options I get. And I see rand and rand n. Perhaps rand is promising. So let's try rand and then press enter. And we get a whole lot of output. I'm going to scroll up a little bit and look at the documentation for this function. We can see some syntax to use it. And down here, we see some examples as well. So it says, for example, rand float 64 to 3, and I see an output of an array with 2 rows and 3 columns of type float 64. Let's try that. Note how after having invoked a command in help mode, we go back to Julia mode. So let's do rand, maybe int 64. And let's say 10 rows and 3 columns. Sure enough, we have a random array. And we specify a range of numbers so we don't get crazy output, say from 0 to 9. Yes, there we go. So that's how we can look up documentation in help mode. Another nice feature of help mode is that you can look up a term across a whole bunch of documentation, doc streams for different modules and functions. To do that, you just wrap the term in quotation marks. So let's do it again with rand and see what happens. And I get a whole bunch of results. All of those doc strings for documentation for objects within the Julia language contain the search term red. So we can inspect more thoroughly each of those doc strings, the ones that seem promising to us. Okay, sorry about that. Also, we have in Julia shell mode. So let's go back to Julia mode. Let me clear the screen here and go into shell mode with the semicolon. I'm gonna press the semicolon now and note the prompt changed to shell now in red. This is useful to interact with your native environment, your system. So let's check our current directory, for example, with pwd. And sure enough, I have my current directory. Let's check our Git repository with, if we have Git, we can do Git status and get that we don't have a repository available. So let's take care of that now. So I'm gonna go to the folder in my documents and then DSCoV talk. And then I'm gonna make a directory, my project, go in there, and then do Git status. So let's create a Git repository. So do Git init. And now let's go back to Julia. Boom. So I did some work in my regular environment. Didn't have to go to a different terminal. Didn't have to exit, launch it back. Didn't lose my environment, my variables that I had already defined in there, and I'm ready to go. That is a very nice feature of the Julia REPL. Take a moment to play around with the REPL in shell mode. With backspace. So that's how I go back to the default mode, which is Julia mode or command mode. Good question. If we are in help mode, after invoking a command, we go back immediately to Julia. Okay. Any questions? Yes. Inside a script. Well, inside of a script, I don't think you can do that, but you get through Julia specific functions, you get access to the environment. You can look at your directory, list files, change directories. But this is more for interactive work. Okay. So yes, in shell mode, I can go back to regular standard mode with backspace, or from any other mode. So from help mode, if I want to go back, again, backspace. Okay. So those are 3 modes from the REPL. There's one more mode, that is the package mode. If you've done any kind of analysis for scientific purposes, a regular concern is the reproducibility of those results. And if you've used environments like Python, and you're coming to Python and you want to do your analysis, then you're confronted with the dilemma. How am I going to be able to ensure that my results are going to be reproducible? And then you see all kinds of tools. Oh, you can use poetry. You can use Conda. You can use Pyanv. You can, and the list never ends. Julia has addressed that problem of reproducibility within Julia itself. You don't have to install some other libraries and kind of like learn their syntax and philosophy or any of that. To do that, to this mode, to manage our packages or environments, we go to the package mode with the closing square bracket. I'm going to type that now. Note the prompt changed to this other PKG prompt. And to see what we can do, we can just press tab a couple of times to get a few suggestions. So let's press tab. And here are all the commands that are available within package mode. Let's take a look at the packages that we have already available in our installation. So we can do status for that, or ST if you're lazy. Press enter, and we can see some output here with all the packages and the versions of the packages that I have installed. Let me invoke it again with the font a little bit smaller. There we go. We can also get some output in the more recent versions of Julia, I think from 1.8. You can see whether a package upgrade is available and whether you have some dependency that's pinning the version of a particular package to the one that you have currently. You get that feedback here with this little green arrows and the yellow arrow with the kind of like the ceiling on top. That means that there's a dependency that's pinning the version to that package. We can update our packages with the update command. Let's see, update. This is kind of dangerous. You can update your commands, your packages. But again, this is ill-advised because you may be having some dependency for your work that's relying on a specific version of your package. So what do we do? Yes. Oh, very good question. That's referring to the version of Julia that you're currently running in that environment. So you could go back to other previous versions of Julia because some packages are only compatible with specific versions as well. So while this is updating here, I'm just going to go ahead and get a new terminal. Launch it with -Q quiet. We don't get this splash screen. And go back to package mode. Make it a little bit bigger. And let's build a project while ensuring that we can share this work with other people. And these other people who are going to be looking at our work are going to be 99% certain that they're going to get the same results as we do in our system. So to do that, remember that we created a folder before in a Git repository. So let's go again to shell mode and do pwd. See, I opened a new terminal. That's a problem. I have to navigate back to my folder. So let's do that. Documents. DSCoV, talk, and I think it was my project. There we go. And now go back to package mode and look at the commands because we may not remember. And the first one that's listed there, because it starts with the letter A probably, is activate. So if we do that, activate, and then space period, indicating the current folder, that's going to create a new environment for us. Clear from blank environment for us to get started to work on a specific problem. So let's do that. Activate space period. And we know here the prompt changed from 1.8 to my proj, which is the name of the folder that we navigated to earlier. And if we check the status, ST or status, you can see that we have absolutely no output. Well, we have some feedback, so let's do it again. That's empty project. Go ahead and create your own environment. Great. Everybody created their new environment? Excellent. Let's add some packages that we're going to use to solve this problem. So to add a package, we do add and then the name of the package. Let's add the benchmark tools package because we want to ensure that the code we're running is as efficient as possible. So let's do this one. It's a nice package for benchmarking. Benchmark tools. And I added an extra D like here. And we have the benchmark tool package added to our environment. Let's ensure that's the case with status. And sure enough, we have benchmark tools version 1.3.2. Yes.
Benchmark tools, and it adds these, its own dependencies in JSON, parser, blah, blah, blah.
Right.
Is there a way to see like the second and third dependencies?
I believe so, Paul. If we go to our folder, our package folder, or environment folder, there's going to be some files that were created when we issued this activate that command before. Those files called the project.toml file and the manifest.toml file. They have metadata about the project, listing the packages that we have added in the project.toml file. We can actually take a look at it. If we go back to shell mode and do ls, you can see there are two files, the two files that I just described. And if we inspect one of them with say CAD project.toml, let's see, we have that one package, benchmark tools. And if we inspected the manifest.toml, that has a lot more information about the dependencies for each of the packages that we just added to our project. Very good question. Any more questions? Yes. Yes, exactly. Right. Julia does some magic to kind of like conciliate differences in versions. So if you have one dependency that's collisioning with another package, Julia tries to kind of like see which is the common version of that one package that's going to make all the packages that you have added to your project work.
So there's a little bit of way. And the manifest is just the graph at that specific place.
Yes. So let's kind of inspect this one. As you can see, this manifest has a lot more detail, has the Julia version, the format of the file, and a whole bunch of other dependencies. For example, benchmark tools depends on JSON, login, printf, profile, and a whole bunch of other packages. And that's kind of like documented with a specific UUID number, kind of like referring to a specific version of those packages that we just added. But in general, we don't have to worry too much about clashes between dependencies of a package that we need and another package. Julia tries to take care of that. Okay, that's why I said before, 99% certain that our analyses are going to be reproduced, because there's always a problem with a new package coming out and then a dependency breaking. Yes.
All packages, some like sort of general repository you can search, or, like that handles all the dependencies, kind of like R or like.
Yeah, this is all handled for us. Right.
And it's all in this like general repository. There's no other like sources of packages.
There are yes, there are what do they call it? It's kind of like a registry. So there's like a lab that does work, say, on image processing, and they have their collection of packages. You can add those registries to your Julia, to the registries from which you can pull packages to install. And those are also handled because those other registries have these metadata, manifest, homo, etc., that the package manager uses to kind of like take care of all these dependencies for us as well. So yeah, that's possible. We can add, we can pull. Right.
And then you can not register your package, but you still allow you to store
Yes.
every package that you have specifies it's a vendor so that's all the package manager.
It is just nice that the package manager takes care of that. Again, no guarantees, but it's high likelihood that things are going to work. Yes.
Back to the sort of question, say like you do get guarantees in the context of the manifest on tone file, like that allows you to recreate the exact environment, right? Other languages not. That's a more accurate representation. It's the exact environment.
I totally agree. But yeah, but sometimes, things happen and then you go, what's happening here? So I'm not saying 100%, but, high probability that things are going to work, right? Questions about the package manager, built-in package manager. We're good? All right. So we can move on to the second favorite thing of mine about the Julia programming language. It is the Julia syntax, especially for scientific computing. Okay. So let's go back to Julia mode and let's create some functions. Okay. So I'm going to create function F. I already did this before, so I kind of cheated, did F parentheses up arrow, and we have a simple function here. Does that look familiar? F of x equals 2x plus 1. Enter. And we get some feedback. F, generic function with one method. Kind of mysterious, right? Let's create another function. G of x and y. G of x and y equals x plus y minus 1 over y plus a function of two variables. Press enter. We get some feedback. G, generic function with one method. Let's use these functions. So I can now do f of 1 or 10, if I mistype the parentheses, and we get 21. And I do G of 1 and 2, making sure we're not dividing by 0 with minus 1 for y. That looks fine, 0.66666. Quick, nice syntax for prototyping quick functions. That is great. We can also do piping. Any R users? Do you like piping in R? We got that here. I was like, hey, just like in R. So as you can see, Julia has taken kind of like the best of the old languages and brought them in, and perhaps got rid of the not so great things. That's the advantage of using a modern program. So let's do some piping here. The pipe operator in Julia is the pipe greater than something. So let's take ends, feed it back into F, and then in turn feed that back. Well, can we feed it into G? Not really, because I need two arguments there, but let's just feed it back into it with pipe greater than, and then the function. And that is F of 0.66666. Yes.
Feed that into G. Does it do what like dplyr does, where you can indicate the position?
Unfortunately not. It doesn't do it. We could use a map, like create the function like on the fly like an anonymous function, kind of like a lambda in Python, and then specify what we're going to do with the second argument. So let's try that. So let's say that I want to take that 2.333, feed it back into F, and then the output, I want it fed into another function. This is how you do it in Julia. So you say X dash greater than, kind of like going into G. And now I have to specify the arguments for G. So let's say X, and then we'll specify a second argument. Say 0 for Y. And let's see if this works. And sure enough, so when we have more complex functions with many parameters, we can do this on the fly lambda kind of style of function. Specify the arguments, fix, and then use the pipe. Or we can just define another function, G, for that specific value of the parameter. Let's try that. Let's do G of X equals G of X 0. So I'm fixing Y with the value 0. And let's see what happens. This works. Surprisingly, I was very surprised the first time I saw this. And then we get this feedback here saying G, generic function with 2 methods. So we didn't lose the previous definition of G with 2 variables. Let's see what happens when we use G with the value 2.33. Well, I don't know really what's in there, but let's test it. So let's do G of 1, 0, and we get 0. And what is G of 1? Again, Y, fix that 0. Do we get the same thing? This still work? Magic. This is one of the things that Julia has been built, of the features that Julia was designed, this spirit. It's called multiple dispatch. And we're going to see a little bit of that later, a little bit more in detail. But this is really nice, right? Who likes multiple dispatch already? Oh, many people. Yes, awesome. We can do also function composition. So we have F and G defined. Let's say that we want to compose the 2 functions, like apply first F, and then to the output apply G. We can use the pipe, but we can also define a new function, either with the pipe operator or with this other operator that does exactly this, function composition. So let me clear my screen here and define a function H equals to G, and I'm going to do this backslash. I'm kind of like escaping something. I'm going to type circ, kind of like the little circle, and I'm going to press tab. And I get this little circle, which is what you might recall from math class about function composition. And then I have G there, but I may have a clash because I have 2 methods of GF, so I'm not sure which one this is going to use. But let's just test it. F. This is kind of mysterious here. I don't know which method it used, but now we can test the function, see what happens. Maybe it'll do magic. H of 1, is that the same as G of F of 1? Yes, Julia knows to pick the correct function for the arguments that we're passing into it. Well, in the second, what do you mean? I cannot use 2 arguments for the definition of H, but I could probably do it for the definition of G. So if I were to call G of f of 1, comma, and specify something else. No, but I do have the other method for G. So let's see what happens. I don't know. Let's see, I'm applying first F. So let's see. 2, is it gonna throw it away? Let me remove this, check. Yeah, we have a problem. So we can't call it because H only has one method and it takes only one. Okay. I'm using 2 arguments for H. It's only one method. So that's probably. I mean, that's a huge ask, but in my view. But yeah, it would be nice if we would do it. Okay. Questions about this first part of the nice syntax of Julia? Dealing with functions, right? Something we do all the time in scientific. Another nice example of Julia's nice syntax is this abbreviated for loops when you have nested loops within each other. So let's do that. I think I have one quick example here. There we go. Let's see. No. Yes, right here. I have an example here, but I don't think I have the X container and the Y container defined yet. So let's do that. Let's define a couple of arrays, X and Y. So I'm saying X, numbers from 1 to 5, semicolon, to add another inline instruction, Y equals 1, colon 2, colon 10. So numbers from 1 to 10 by steps of 2. On that, let's inspect X. There we go. Let's inspect Y. There we go. It's a range object. It's not actually generating the actual values of those in those ranges, right? For efficiency purposes. Now let's write the for loop. Let's say that we want to traverse X first, and then do something with every member of X with every member of Y. So let me cheat a little bit. And here we go. We don't have to write 3 for statements. And then in Julia, you have to delimit a for loop or while loop with the end keyword. So we would need another 3 ends afterwards. We were saving all of that, just using one single instance of the for keyword to define the loop. And then we list the containers. We choose indexing variables and run it. Let's see. Yes. This is equivalent to for I in X, and then for J in Y, and then for K in 1, 3, and then this statement at show 1 plus J plus K. Any questions about this before I run it? You may want, one of you may be wondering, what is this at show business that I'm not using, like print X I plus J plus K? Well, I'll show you why I'm not using print I plus J plus K. Let's run this. And I scroll back up. And I get the output and the expression that generated that output with this at show magic expression. This is great for inspection later when you're inspecting the output of your code at different points. Okay? Do you like the abbreviated nested for loop syntax? Yeah, me too. Yeah, well. Julia also has Unicode support. Let's go back and create another function. Have you seen these symbols before over here? This mu and sigma. Any statisticians? Let's see. So G of X equal, oh, I want to specify this mu business with, again, backslash mu. If you've done any LaTeX drafting, this is kind of like we do this special symbols, but we don't have to go to math mode. We have it available right away. So mu space, excuse me, tab. We got the rendered version of that code, mu, and then backslash sigma. We got sigma. Let's specify default values for these. Maybe 0 for mu and 1 for sigma. Sounds reasonable. And then let's normalize x by subtracting mu and dividing by sigma. And we get some output, G, generic function with now 3 methods. We haven't lost the previous definitions of the function, G, the previous methods. G. Let's see what else we can do with Unicode in Julia. Let's do backslash and then tab to get some suggestions. Whoa, there's a lot that we can do. Top, square, SQR. Let's test that one. Clear? Smile? Do you need the colon or not? I'm not sure. Let's see. Yeah, there we go. Well, it's not rendering on my own terminal, but it might in like in a Jupyter notebook or something. Yes, that's right. With backslash tab, it'll show you all of the options. I don't know if you would, it might be somewhere, documented somewhere, but a quick way to tell is by doing this backslash tab and take a look. And other stuff that start with circ. Circ, no C, let's see. Yeah, there's a lot of stuff. And over here, you can see circ listed right here. Okay.
If you type a question mark before that symbol or anything else, will show you whether it's there that already exists, the function.
Right. Or try it out. See what happens. All right, maybe we can get to one or more, 2 things from this list. Array comprehension. Anybody coming from Python and likes lists comprehension. They work just the same in Julia. So let's see. I have a comprehension that I wrote before. There we go. Well, even older one. So let's say that I want to do I over 3 for I in 1 to 10. For I for in, yeah, that's that. Let me go back here. And there we go. Array comprehension. Are you liking the Julia syntax? Yeah. Also, we have in Julia logical indexing. So I have this 10-element array. Let's say that I have another array with Booleans. So let's do that. B bool equals rand. Let's specify bool because I want a random array of bools of size 10. Here we go. And now we want the positions where we have true in this array. In the previous array, which I already lost because I wanted to use ands. But let's create another one. Array equals that. And now I want to do indexing with bool, R bracket, and then bool. And I filtered the R array with by the indices in bool that were true. And get the output. This is something people do in R and MATLAB all the time. Okay? And maybe one more thing. Let's see, can we go to the next one? Oh, for loops being fast. Why am I bringing this one as a favorite thing of mine? Because if you've done any coding in R or Python, the first thing they tell you is do not use for loops. I'm like, what? Why are you even teaching that in computer programming class? It turns out that in Julia, for loops can be relied on. So let's test it. Let's write a function that adds two arrays using the dreaded for loop. So I think I have my sum here, my add, and I have this definition. So let me show you what I'm doing over here. I'm using, again, the quick function syntax in Julia. I added this exclamation point indicating that I am going to mutate the first argument that I'm passing to the function and the other arguments. And I have the for loop, index variable I, and I'm using this each index function to not have to count the number of elements in A and then use it as an index later. I can just use each index. And then down here, I'm doing the sum element-wise and saving the output back into the C array, standard for loop computation, right? So let's define this function. And now we're gonna benchmark it. So let's first create the two arrays, A and B, using random arrays. So A equals 1,000 by 1,000, relatively probably okay for benchmarking. And then let's create the B array, B, and also the container we're gonna use for the result. So let's do C also, why not? Okay, and now let's load a package to do that for benchmarking. So to load a package, we do using, and then the name of the package. Benchmark tools, we load it, and now we're ready to benchmark. So let's first do from benchmark tools, B time, and do A plus B, and see how long that takes. This is gonna run it many times and kind of do some statistics. It's gonna report the minimum time at this time. Yeah, built-in plus some array addition. And we get some output here saying 2.012 milliseconds, okay? Now let's do it with my add that we defined earlier with A, B, and C. Oops. Let me just get rid of that. My add one. Well, I thought I had a one there, but let's just get rid of this. And add B time macro call at B time. Remember, it was about 2 milliseconds. This is a for loop. And with this, we're gonna end the talk for today. Thanks for coming. 700 microseconds. Absolutely.
Can you find my the allocated comparing to the
Absolutely, we can do that. But in the for loop, we need to store the sum somewhere. So where are we going to put it?
Outside of the function, so you're not taking the function, it's not timing the allocation of the seed.
Yeah, we can do that offline. But for now, we're going to end the talk here, and then I can take the challenge. I believe so. Yes. So the work that Benchmark Tools is taking to do this statistical analysis of the iterations is not included in the benchmark. The time in the benchmark. Yeah, that's removed. Okay.
Do you know what they use? Not allocated. What did it say for allocations for the HI? Yes, it looks like that. I'm curious. I guess what I'm curious is like,
Maybe the difference we're seeing is due to the time that it's taken to allocate the data. Maybe.
if the simple form is the fastest way, that's what Julia has explained. But I mean, from here, it's obvious that the allocation of C is going to be a problem, right, in the A plus B.
Well, we can look into it. Yeah. So formally, this is the end of the talk. Now I'm happy to take more questions. Yes.
The argument passing is by reference. So
Yes. It is passed by reference, exactly. So we are not creating a new object when we are grabbing this C inside the function. So, yes, it is a pass by reference language. For mutable objects, right? Mutable objects. So if I cannot modify an int or a float, it needs to, the object that we are mutating has to be a mutable object.
But a variable that has a
Yeah, it's fine because it's containing ints. Yes. So C, when we defined it, was a matrix of floats.
But if C had been a scalar, the variable holding a scalar, that's passed by reference.
Yes, that's passed by. So
By default, so inside. So
yeah, that's getting a little bit into the weeds, right? Language.
so like what is the behavior of the passive by reference
Right. Mm-hmm. So arrays in general, unless we declare them immutable, we can do this mutation operation by passing by reference. Yeah.
So if I function out of X that sets X to some other value, and see that it doesn't change X.
Right. Exactly. So that's an immutable object, and we are not mutating it. So if we don't specify the object within the function in which we are storing the results, then that creates a new object in memory for storing those results, not referencing the other that was in the other scope outside. Any other questions? Great question. Okay, thank you.